So in this video, we're going to talk about higher degree polynomial equations. So I've got an equation. I want to find the solution. So I've got 2x cubed plus x squared plus 2x plus 1 equals 0. So the first thing I do, I think, okay, there's 1, 2, 3, 4 terms. 4 terms automatically makes me jump to factor by grouping. Group the first two, group the second two, see if there's anything in common. Well, between these two, it looks like I can pull out an x squared here and an x squared there. So an x squared comes out. And what do I have left inside? I have 2x plus 1. And then over here, I already have a 2x plus 1. There's nothing in common between those. So GCF here is just 1. And then I have my 2x plus 1 here. And so I have my 2x plus 1 and my 2x plus 1. And so I'm going to factor that out of both. 2x plus 1 times x squared plus 1 equal to 0. And now I'm going to set each piece equal to 0. 2x plus 1 equals 0. And x squared plus 1 equals 0. So x squared plus 1, how do I solve that? Well, I'm going to move the 1 over to the other side, and I have x squared equals a negative 1. To get rid of the square, I take the square root, but when I square root, I have a plus and a minus. However, when I'm taking the square root of a negative 1, that's the definition of I. So x is equal to plus or minus I. Okay? And then over here on the left, we've got subtract 1 from both sides. 2x equals negative 1. And therefore, x is negative 1/2. So my solution set is negative 1/2, negative I, and positive I. And those are the solutions to this equation right up here. Okay, higher degree. So we're talking about degree 3 here. Up to this point, we've just been doing quadratics, linears. So next example I've got is a 2x cubed minus x squared equals 15x. First thing I want to do is I want to get everything to one side, set it equal to 0. So I want to move the 15 over. So the inverse of plus 15 is minus 15x. When I do that, I get 2x cubed minus x squared minus 15x equals 0. Now, I look at this and I say it's a trinomial, okay? But it's more than just a trinomial. It's a cube, so I can't just do my AC method here. So first thing I want to do is, in factoring, is think, okay, GCF. What's in common between all three of these? All three of them have an x. So I'm going to factor an x out. And if I do that, I'm left with 2x squared minus x and then minus 15, all equal to 0. So this tells me x equals 0, and this tells me 2x squared minus x minus 15 is equal to 0. Now this one's finished. To do this other one, I need the AC method. AC says I multiply A times C, the lead coefficient, times the constant, so that's negative 30. And then I want it to add to negative 1. So 5 times 6, if that's negative 5, that's negative 5 plus 6, that's 1. But if I make it negative 6 and 5, negative 6 plus 5 gets me negative 1. Bingo. That's what I want. I want it to add to negative 1. So this is 2x squared minus 6x plus 5x minus 15 equals 0. 4 terms, factor by grouping. Group the first two, group the second two. What's in common? There's a 2 and an x. So I'm factor a 2x out. And I have an x minus 3 inside. Now here, I have a 5x and a 15. I'm going to factor 3 out, so plus 3 comes out. And then I have a, I'm going to factor a 5 out. So let's factor 5 out. Okay, so a plus 5 comes out. And I'm going to have x minus 3 inside. So now I have x minus 3 in both of those. So I'm going to factor x minus 3 out. And then I'll have the 2x plus 5 remaining. And if I set each of those pieces equal to 0, x minus 3 equals 0, 2x plus 5 equals 0, x equals 3, that's another solution. And then minus 5, 2x equals negative 5. Divide by 2, I get x is equal to negative 5 over 2. So I've got 3 solutions for this problem. My solution set is 0, 3, negative 5 over 2. Okay. All right. 2 more. So I've got this one right here, a little bit different character right here. This one is x to the 4th. Interesting. So the first two we did were x cubed, so this is x to the 4th. We're kicking it up a notch. Plus 5x squared minus 36 equals 0. Now, this one is a trinomial. However, it's not a polynomial. It's not a quadratic. It's a quartic. Okay, it's raised to the 4th power, degree 4. Polynomial, but it's very similar to AC method, right? AC method would be like ax squared plus bx plus c equal to 0. Okay, we have something squared down to something linear to a constant. Well, I got my constant, but then the squared, and then double that squared is the 4th, right? So very similar. So there's a trick here. And it's called a U substitution. U for ugly, right? Ugly. So an ugly substitution. So if I make U equal to whatever this middle term here is, so for this one, it's x squared. Now all of a sudden that becomes linear. And so what do I mean by that? Okay, so everywhere I see an x squared, I'm going to put a U. And everywhere I see an x to the 4th, well, how do I make this x to the 4th? If I do x squared squared, that's u squared, that's x to the 4th, okay? So what does this become? This becomes, well, x to the 4th is equal to u squared. This becomes plus 5u, and this is still minus 36 equal to 0. And now we're in this form where we can use our trinomial t-chart. And so the trinomial t-chart says multiply to negative 36 and add to 5. Is that possible? 9 and 4. Negative 4 plus 9 gets me 5. Yep, that's possible. Okay, so I have u squared minus 4u plus 9u minus 36 equal to 0. 4 terms factored by grouping. What's in common? There's a u in common, so I take a u out of both of those. I get u minus 4. And then out of these, I'm going to take a 9 plus 9, and then u minus 4 equal to 0. Both of these have a u minus 4, so I'm going to pull the u minus 4 out, and I have a u plus 9 left over. Set this, each piece equal to 0, u minus 4 equals 0, and u plus 9 equals 0. Solve for u, plus 4, u equals 4. Minus 9, u equals negative 9. Now, you might be tempted to write this as your answer, but I want to caution you, okay? This is in terms of u. Your problem you started with was in terms of x's. So we need to get back into terms of x's. So how do we do that? Well, u is equal to x squared, so I replace u with x squared. And now I need to solve this equation for both of those. And so to do that, I take the square root of x squared and the square root of 4, and I get the plus or minus. Square root of 4 is 2. So x is equal to plus or minus 2 here. If I take the square root here, as soon as I see a negative in the square root, I automatically think I. So this is plus or minus I, square root of 9. Square root of 9 is 3. So x is equal to plus or minus 3i. And x is equal to plus or minus 2. So my solutions are 2, negative 2, 3i, and negative 3i. So 4 solutions for this quartic that I had up here, okay? So it's a new trick. That's a new trick, doing a U substitution, okay? A U substitution right there. Let's do one more with a U substitution just because it's new and, you know, helps to see multiple examples. So u to the fourth plus 21y, y to the fourth plus 21y squared minus 100 equals 0, okay? So once again, I see this power to the fourth. I'm thinking U substitution because u to the fourth, that is ugly. So U substitution, I look at this middle term right here. That's typically where my u is. So u equals y squared, okay? U equals y squared. Then what's going to happen? What will we do? Okay, so if u equals y squared, then u squared is equal to y squared squared, which is y to the fourth. So this becomes u squared. This becomes plus 21u, and this is still 100 negative equal to 0. And now I can factor AC method, add to negative 100 and multiply to negative 100 and add to 21. Negative 25 and 4, that's negative 100, and it adds to negative 21. So this is u minus 25 and u plus 4. If you run through the AC method, you can get this. Or if you see the shortcut, since a in front is a 1, once you get these two numbers right here, you know a positive 4 goes for positive 4 here. Negative 25 goes for that negative 25 there. Okay? That only works if the coefficient in front is a 1. If a equals 1, then you can use a shortcut. Otherwise, you have to do that u squared minus 25u plus 4u minus 100 business. Factor by grouping, pull out the u minus 25, pull out the 4, u minus 25. Factor the u minus 25 out of both of those. U plus 4 equals 0. And then you get to the same place that you were at. Okay? So, set this each piece equal to 0. U plus 4 equal to 0. And now add 25 to both sides. And I get u equals 25. And over here, minus 4. And u equals negative 4. But once again, our problem started in terms of y. So we need to finish in terms of y, and u is equal to y squared. So I'm going to replace u with y squared, and y squared here, and then I'm going to solve for y by taking the square root, and when I square root, I get a plus or minus. Square root of 25 is 5, so y is equal to plus or minus 5, and y is equal to, well, square root of a negative number. A negative number is going to get me what? It's going to get me I, and square root of 4 is 2, so 2i. So my solutions are 5 and negative 5, 2i and negative 2i. Okay? All right, hopefully, excuse me, hopefully that helps you work through your problems. All right, good luck.